Picture this. A single factory floor big enough to hold 4 football stadiums, yet every 9 seconds a brand new match-ready ball rolls off the line. Clean, shiny, and already sold to a pro league. Blink, and you might miss how fast each step moves. Lasers cut bright white panels. Workers race clocks that punish even a 2-second delay. Robot cameras kick out any piece that is even a hair off center. Behind all that speed, there's a silent battle. Big brands want perfect balls at the lowest price. Workers want fair pay for each stitch, and engineers try to build machines that could replace hands in the future. Stay with us, because what happens inside China's mega ball plants is not only about sports gear. It is about people, robots, and who wins the game of modern work. Before sunrise, giant trucks arrive at the gate. They carry huge rolls of synthetic leather and sheets of polyurethane. Each roll weighs nearly half a ton. The guards scan the papers and wave them through. Inside, the cold air blasts from overhead ducts. The smell of oil and glue fills the air. Workers in bright vests move the rolls with forklifts. They stack them on metal racks. Each rack can hold hundreds of rolls. This is the first step in making a soccer ball. Next, sheets of material are fed into computer-controlled cutters. These cutters use lasers and knives to slice the sheets into 32 precise panels. The blades hum as they move. Each panel has a slight curve and a thin black line around its edge. This line marks where the stitches will go. The machines push the panels onto conveyor belts. Workers stand by to remove any panels that are torn or miscut. They do this in seconds, so the line never stops. Once panels pass this check, they go to the stamping station. Big stamping machines press brand logos and colored patterns onto each panel. The machines heat up to melt the ink onto the surface. The ink cools in an instant. Then robot arms peel the panels off and place them on trays. Each tray holds a full set of 32 panels. These panels will come together to form one ball. Meanwhile, engineers in white coats watch screens. They track data from every machine on the floor. If a cutter slows down by even half a second, alarms flash. The engineers check the readings. They can pause the entire line to fix a glitch. This way, they keep waste low and quality high. They know that brands pay big money for zero defects. After stamping, the panels travel to the stitching room. Here, thousands of workers sit in rows at sewing machines. Each worker takes one panel set at a time. They sew the panels together by hand or by machine, depending on the model. Standard balls use machine sewing, but Pro League balls use hand sewing for tighter seams. Hand sewing takes more time, but it makes the ball more rounded and balanced. Each full ball is stitched with exactly 640 stitches. Workers count every stitch out loud, 1, 2, 3, up to 640. They move fast, but they never skip a number. One missed stitch can spoil the ball's flight path in a match. The pace is intense. A timer above their heads shows how many seconds remain. They have exactly 90 seconds to stitch one ball before the next set arrives. If they are late, the line slows down and costs the factory money. When stitching is done, each ball is turned inside out so the seams hide under the surface. This makes the ball smoother and easier to kick. Workers press the seams with rubber rollers to remove wrinkles. Then they spray the ball with a light coat of water-based finish. This helps the color stay bright and the surface feel soft. Next comes quality control. Robot cameras spin each ball under bright lights. They check for roundness, panel shape, and seam thickness. Any ball with an error rate above 0.5 millimeters is kicked out. Those balls go back to the panel stage for repair or recycling. Good balls move on to the inflation test. At the inflation station, workers pump air into each ball. They use a gauge that measures exact pressure. The standard is 0.6 bar for match balls. Once the ball holds pressure for 10 seconds, it is ready for the bounce test. A machine drops the ball from 2 meters high onto a steel plate. The ball must bounce back to a height between 1 and 1.2 meters. If it fails, it goes back for repair. Balls that pass the bounce test move on to the water test. Workers dunk the ball in a tub of water and spin it. The water must bead on the surface. It must not soak into the seams. This tests the water-resistant coating. After the dunk, the ball goes under a hot lamp to dry quickly. Only after passing all tests does a ball get the brand name and model code printed on it. The print machine stamps each ball with silver ink. Then a clear coat is sprayed to seal the print. This final finish makes the logo last for matches in rain or snow. While the balls race down the final conveyor, another team packs them into boxes. Each box holds 4 balls. Workers stack the balls carefully to avoid scuffs. The boxes close with a click. A printer on the box adds a barcode with the date, factory code, and batch number. This lets brands trace any ball back to the exact time and line that made it. The sealed boxes move to the warehouse. Rows of shelves tower overhead, packed with thousands of boxes. Forklifts zip between aisles, guided by lasers and sensors. Each box has a digital tag. Warehouse computers track every move. If a brand orders 50,000 balls, the system picks the oldest boxes first to keep stock fresh. Global shipping is the next step. Most balls are sent by sea in massive shipping containers. Each container holds 1 million balls. The ports near the factories use giant cranes to load and unload these containers in minutes. Then the containers go by freighter to ports in Europe, Africa, and the Americas. The journey can take weeks. Rain at sea can damage some boxes, so cores are lined with plastic wrap for protection. Meanwhile, back in the sewing halls, the debate continues. Some workers say stitches by hand make the best balls. Others argue that machines are faster and do not get tired. Engineers are testing new robots that can sew panels in under 60 seconds. If these robots succeed, workers worry they could lose their jobs or have their wages cut. Brands push for lower costs too. They haggle over the price per ball. A top league ball might cost $20 to make. Brands want that cut to $15. The factory managers push back, saying that hand-stitch models need the extra $5. This battle plays out in emails and calls between marketing teams and factory chiefs. At the same time, factories face pressure to go green. The glue and finishes used can emit volatile organic compounds. To cut emissions, some plants install scrubbers on their vents. Others switch to water-based glues. These changes slow production briefly as lines adapt, but they help keep the air cleaner for workers and reduce the factory's carbon footprint. Health and safety is also a hot topic. The noise from cutters and stamping machines can reach 90 decibels. Workers wear ear protection to avoid hearing damage. Floors can be slippery from water sprays. The factory has strict rules to keep the floors dry and workers safe. First aid stations stand at every corner. Some of the earliest soccer balls were made by hand in small workshops. Those balls cost a fortune and had uneven bounces. Then machine sewing arrived in the 1960s. Factories moved to China and grew bigger and faster. Now these mega plants make millions of balls a year. They ship more balls in a day than small workshops made in a decade. Inside R&D labs, engineers test new designs. They study how panels meet at seams and how dimples on the surface affect airflow. They build wind tunnels to see how a ball curves in flight. They test foam cores to find the best rebound. These tests can take months. The final design goes to a short production run. Workers make a few thousand balls to test on real players. Only after players sign off does the design go to mass production. Even now, mechanical failures happen. A cutter blade can break, sending panels flying. A glue nozzle can clog, stopping lines for minutes. When machines break, a team of technicians rushes in. They carry toolboxes and spare parts. They repair the line and get it going again. Every downtime minute costs thousands of balls in lost output. During big sports events, brands place huge orders. A World Cup ball order might need 2 million balls. Factories shift to 3 shifts a day, 7 days a week. Workers get overtime pay, but also face fatigue. Managers rotate shifts to keep people fresh. Still, the pressure to meet deadlines is intense. The factory also exports to smaller markets. Local leagues in Africa or Asia get budget balls. These balls use machine stitching and a cheaper cover. They still must pass basic tests, but have fewer rounds of quality control. This tiered system lets factories sell to both pro leagues and amateurs. Inside these halls, the quiet fight continues. Workers talk of fair pay. They want more for each ball stitched. Managers cite global competition and thin profit margins. Unions have formed in some regions. They negotiate small raises once a year. But brands still push to keep costs low. It is a tug-of-war between profit and people. Despite the battles, each ball that leaves the line carries a piece of many lives. There is the steel arm of the laser cutter operator. There is the hand of the stamper who checks the logo. There is the eye of the quality controller who watches the robot camera. There is the breath of the packer who seals the box. And there is the hope of the delivery driver who truly sees the joy these balls bring to young players in every corner of the world. In the end, these mega factories do more than make balls. They show how work and machines mix. They show how a simple sport object can become the center of big business fights, new tech tests, and real human hopes. Every time a player kicks a ball in a stadium or in a back alley, that ball might come from one of these mega halls. It is a symbol of how fast and far our world can mass produce. And it is a reminder that behind every ball there are thousands of hands and wires racing against time to win a very different game, one of work, machines, and people.